Graphs of quadratic functions. In this video, you're going to learn how to graph the quadratic functions and describe the graph of the quadratic function. Let's take the example y is equal to x squared minus 2x minus 3. In order to graph this, we have to first transform it to its vertex form to determine the value of h and k. First, we have to group the terms with x, and that is x squared and 2x. Second is we have to factor out a. Since the value of a in this equation is 1, we will still arrive at the same equation. Third step is we have to make the phrase inside the parentheses a perfect square trinomial by completing the square. Doing that, we have to divide negative 2 by 2, which will give us the answer of negative 1, and negative 1 squared is positive 1. Thus, we will have the resulting equation y is equal to the quantity x squared minus 2x plus 1 minus 3. The fourth step is we have to deduct the same amount we added to keep the equation balanced. Since we added 1, we have to deduct negative 1, or we have to deduct 1 to the equation. The fifth and the final step is that we have to express the perfect square trinomial as a square of binomial. This perfect square trinomial is equal to the quantity x minus 1 squared, and negative 3 minus 1 is equal to negative 4. Now that this is in its vertex form, we can now determine the value of h as 1 and the value of k as negative 4. Now, to graph this function, we have to first plot the coordinates of the vertex h1 and k negative 4. Then we have to choose at least one value of x on both sides of the axis of symmetry and solve for the y. The axis of symmetry is the line that divides the graph in half, such that the other half is the reflection of the other. In this case, this is the line of symmetry. Now we have to pick one value of x from the right of the axis of symmetry, that is x is equal to 2, and one value from the left of the axis of symmetry, that is x is equal to 0. Now solving for the value of y, if x is 2, let's substitute 2 as the value of x. That will be y is equal to 2 squared minus 2 times 2 minus 3. Simplifying, we will have y is equal to 4 minus 4 minus 3, or the final answer will be y is equal to negative 3. We now have the coordinate 2, negative 3 as our second point. Now let's solve for the value of y if x is equal to 0. If x is equal to 0, it will be y is equal to 0 squared minus 2 times 0 minus 3. The first and the second term will be 0, giving us the final answer as y is equal to negative 3. Now let's plot the points with the coordinates 2, negative 3, and 0, negative 3 on our Cartesian plane. This will be 2, negative 3, and 0, negative 3. The last step is we have to connect them by forming a smooth curve. This graph will now be the graph of the function y is equal to x squared minus 2x minus 3. Let's take another example. Y is equal to negative x squared plus 4x minus 1. Transforming it to its vertex form, grouping the terms with x, we have y is equal to negative x squared plus 4x minus 1. Factoring out the value of a in this equation is negative 1. So we'll have the equation y is equal to negative quantity of x squared minus 4x minus 1. The third step is we have to make the phrase inside the parentheses a perfect square trinomial by completing the square method. In this case, the middle term is negative 4 divided by 2 will give us the answer of negative 2, and negative 2 squared is equal to positive 4. Thus, we will have the equation y is equal to negative quantity of x squared minus 4x plus 4 minus 1. The fourth step is we have to deduct the same amount we added to keep the equation balanced. Since we add 4 multiplied to negative 1, we actually added negative 4. To keep it balanced, we have to add positive 4 to the equation. Fifth and last step, we have to express the perfect square trinomial as square of binomial. Doing that, we will have y is equal to negative x minus 2 squared plus 3, because negative 1 plus 4 is positive 3. And the factor of this perfect square trinomial x squared minus 4x plus 4 is x minus 2 quantity squared. Now we have the value of h as 2 and the value of k as 3. Now to graph this, let's plot the points of the vertex 2, 3, and then we're going to select one value of x from both sides of the axis of symmetry. In that case, from the right we have x is equal to 3, and from the left x is equal to 1. Let's solve for the value of y. If x is 3, substituting x as 3, we have negative 3 squared plus 4 times 3 minus 1, which will give us negative 3 squared is 9, 4 times 3 is 12, negative 1. Simplifying, we have the value of y as 2. Solving for the value of y, if x is equal to 1, we have y is equal to negative 1 squared plus 4 times 1 minus 1. Simplifying, we have negative 1 squared. 1 squared is 1. Multiply it to negative 1, it will be negative 1. 4 times 1 is still 4, and minus 1. Y is equal to 2. Plot the points and connect them by a smooth curve. Now let's plot the points 1, 2, and 3, 2. Connect them to form the graph. This will now be the graph of the function y is equal to negative x squared plus 4x minus 1. Some points to remember. The graph of the quadratic function is called a parabola. The opening of the graph is determined by the value of a. If a is greater than 0, the graph opens upwards. If a is less than or equal to 0, the graph opens downwards. The axis of symmetry is given by the equation x is equal to h, and k is either the maximum or the minimum point of the function. K is the maximum point if the graph opens downwards. K is the minimum point if the graph of the equation opens upwards. The domain of the function is the set of all real numbers, and the range is either y such that y is greater than or equal to k if the graph opens upward, or y such that y is less than or equal to k if the graph opens downwards. Let's try describing the graph of this function. Y is equal to the quantity x plus 2 squared plus 3. Let's determine its vertex, the opening of the graph, whether the vertex is a maximum or minimum point, the equation of the axis of symmetry, and the domain and the range. The vertex of this function is negative 2, 3. The opening of the graph, since the value of a is a positive number, meaning the a is greater than or equal to 0, the opening of the graph is upwards. Since the graph opens upward, the vertex is the minimum point. The axis of symmetry is given by the equation x is equal to the value of h. The value of h is negative 2, giving us the equation of the axis of symmetry as x is equal to negative 2. The domain of the function is all real numbers, and the range, since it opens upward, it will be y such that y is greater than or equal to 3. 3 is the value of k. Let's try another example and describe the graph of y is equal to negative quantity x plus 1 squared plus 5. Same thing, we have to identify the vertex, the opening of the graph, whether the vertex is a maximum or minimum point, the axis of symmetry, the domain, and the range. The vertex of the graph is -1, +5. Opening of the graph, since the value of a is a negative number, it will be downwards. Since the graph opens downwards, the vertex is now the maximum point. The equation of the axis of symmetry is given by x is equal to h is equal to -1, which means the axis of symmetry's equation is h is equal to x is equal to -1. The domain is always the set of all real numbers, and the range, since it opens downwards, it means y, the set of all y, such that y is less than or equal to the value of k, which is 5.